Deep here, we're going doubleheader. It's Friday. It's 3:30. We can crank one more of these out. Multiplying fractions. So we start basic. Notice that we break it into its. Actually, we just break it up. We put it under the same. Put the numerators and the numerators together. So you have 3 times 5. Notice 3 times 5. You have 4 times 8. 4 times 8. Some students will break it into its prime factorizations. So you have 3 times 5, which is primed. 4 is 2 times, well, nothing cancels there. Yeah, that's a horrible example. This one's a much better one. 5 times 9 over 6 times 10, and 5 times 9 is broken down to 3 times 3. 6 is 2 times 3. 10 is 2 times 5. So we can see its prime factors, which will cancel, and then we are left with 3 over 4, 3/4. And that's really what we're doing. We're going to do the same thing when we have variables in there. So I'll do this, 3 times 5 times 7 over 7 times 3 times 3. Not sure if I'm going to do this the whole entire time, but maybe. We'll see how quickly we get, or how fast it is. 5 times 2 times 2 over 2 times 2 times 2 times 2 times 3 times 5. And here's another thing. You should be able to do prime factorizations that easily in your head. Now the fun thing about this is everything in the numerator canceled, so you're left with a 1 up there, because 5 over 5 is equal to 1. 2 over 2 is equal to 1. And then you're left with 12 in the denominator. 2 times 2 is 4 times 3 is 12. Yeah, we'll do 2 times 2 times 3 times 2 times 7 over 7 times 3 times 3. The 3 will cancel, the 7 will cancel. That leaves us with 8 over 3. 2 times 2 times 2 is 8 over 3. We have negative, and the negative can stay out there. 5 times 2 times 2 times 2 times 2, and 2 times 5 times 5. The 5's cancel, the 2 cancels, and we're left with negative 8 over 5. That negative can go in the numerator, it can go in the denominator, or it can just go outside even with it. That's an okay answer, that's an okay answer, that's an okay answer. 2 times 5 times 3 times 3. I took all those numerators. Notice it's just this numerator, this numerator, this numerator. Just was rewritten there. We'll take each of the denominators, break them into its prime factorization. So 5 times 3 times 3 times 2 times 5 is my denominator. And now we'll cancel. 2 cancels with the 2 in the denominator, 3 in the denominator with 3 in the numerator, 5 in the denominator, 5 in the numerator, 3 in the denominator, 3 in the denominator. That leaves us with 1 over 5. Now, explaining how we can also do it is we don't even have to rewrite it. We can just see 4 cancels with 8 2 times, 5 cancels with 15 3 times, 2 cancels with 16 8 times, and we're left with 1 times 3 times 3, which is 9. 1 times, that's 8. Now notice the difference is things can get lost in there when you're canceling and stuff. Now we're going to square first, so that is negative 3/2 times negative 3/2, which equals 9/4 times 8/9. We have to do exponents first before multiplication. We can cross out the 9's, and the 4 cancels, and we're left with 2. Negative 3 squared is 9 over 1 times 25 over 12. What goes in? 9 doesn't go into 12, so now we have to find a common factor. So 3 goes into 9, 3 goes into 12, 4, and nothing else cancels. So now we multiply the 3 times 25, which is 75 over 4. Now we'll introduce variables, and so we have x squared will go into 2 of those, and 4 goes into 8 2 times, so we're left with 2x. The 5 and the 10 become 2. The 7 and the 21 becomes 3. The y's will just cancel, and you're left with 2 over 3. And again, I mean, you can lose things in this canceling. This is where you won't lose anything, but I'll show you in the next one. Or maybe not the next one. Yeah, so I'd much rather you do 6 times 5 times x over x times 2 times 2. Well, we could even just go 2 times 6, because now we can just break up into factor pairs that will cancel. So you don't have to break it into its prime factorization. We're just going to break it into a factor that cancels, and the x's. Now, I'm not confused about what's left over. I see the 5. I see the 2x. So this method takes a little bit more time. We'll do 2 times 3 times w times v squared. And then we have v times 3 times w times w. So the 3's will cancel, the v will cancel, the w will cancel, and that leaves us with 2v squared over w. We'll write 4 times 2 times a times 11 times 3 times b, and 11 times b squared times 4 times a times a. Now that takes lots of thinking and coordinated efforts and seeing the answer, but it works. And we're left with 6 over ab squared. We're always going to write it in alphabetical order, standard form. And that would be my answer. So 2 times d times e squared times f over 5 times e squared times f times 2 times d. The 2's will cancel, the d's will cancel, the e squares will cancel, the f will cancel, and that's it. So we're left with an f in the numerator and a 5 times 2, which is a 10. 5 times 2. That's it. F over 10. 3 times r times s times 4 times 2 times t times t. 4 times t times 3 times r times s. The 3 cancels, the 4 cancels, one of the s's cancel, one of the t's cancel, the r cancels, and nothing else. So we're left with 2st over 3. Excuse me. That's good. 17. X minus 3 times 2 times x over x times x minus 3 times x plus 3. X minus 3 cancels, the x cancels, that's it. You're left with 2 over x times the quantity x plus 3. This becomes x minus 2, x plus 2 times, no, we can leave that as 4 times x over 4 times 2 times x times 5 times 5x plus 2. I factored the 5x plus 10. Those cancel. The 4 cancels. The x cancels. And that's it. We're left with x times the quantity x minus 2 over 10. Really efficient. I mean, it's nice. That's the difference of squares times the a over a times a times negative 2. I factored out the negative and made this a minus b. So I rewrote this as negative a plus b, factored out the negative, and we got ab. And then I took that negative and put it with the 2. Why? I don't know, just because I could. A, we're left with a plus b, it's a horrible b, over negative 2a. M times m minus n times m plus n, difference of squares, 3, negative 3 times m minus n times m times m. One of the m's is going to cancel, the m minus n is going to cancel, and that's it. We're left with m plus n over negative 3m. All right, now we may have to simplify. Oh, all right, well, we know that this is a minus 4 times a minus 4. And that's a squared over 4 squared, which is a squared over 16. Now, we also need to know that you can distribute exponents. So we could have just gone directly to this and then have this as our answer. So I'll be doing that. I will be distributing that exponent in. You get c to the third over 3 to the third, which equals c to the third over 27. You should know your cubes. That's m to the third over 5 to the third, which equals m to the third over 625. Now, as I say, you should know your cubes. 125. That's 5 times 5 is 25 times 25. Sorry. You knew it was going to happen, right? I knew it. I knew I was going to regret making that statement. 4 to the third, y to the third over 64, I think. Pretty sure. Ooh, this is good. So when we distribute this, you got to distribute it to the 2, the n, and the 5. So each of those pieces. So it's 2 to the second, n to the second over 5 to the second, which equals 4n squared over 25. That's going to equal 3 squared times x squared over 4 squared, 9x squared over 16. 3 squared w squared over 7 squared, 9w squared over 49. 7 squared b squared over 2 squared. 49b squared over 4. Now you got a lot of things. You're distributing the 2 to the a, to the 3, to the b cubed. So 2 squared times a squared over 3 squared times b to the 3 times 2. When we have a power of a power, we're going to multiply those exponents. So that is 4a squared over 9b to the 6th. Tricky problem there. So 4 squared times m squared over 5 squared times n squared times 2. 16m squared over 25. That's m squared, n to the 4th. Let's distribute. We have the negative we're going to distribute, the x, the 3, and the y. So we have negative 1 squared times x squared over 3 squared times y squared. Negative 1 squared is 1, x squared over 9, y squared. Good little problem there. This negative is outside, So the base of this exponent is just Chewbacca. So that's going to equal the opposite of 4 squared times b to the 3 times 2 over 5 squared, which is the opposite of 16b to the 6 over 25. X squared times y squared times y over x. Now we do exponents before multiplication. Now we cancel, and that's going to cancel, and that is left. That leaves us with x over y. Let's distribute those. That's 2 to the third times x to the third over y to the third times y squared over 4. Let's simplify that. That's 8x to the third y to the third times y squared over 4. Now we can cancel. Start simplifying. 4 in the denominator, 8 in the numerator. We have y squared in the numerator is going to cancel with 2 of those. You're left with just 1 there. So my answer is going to be 2x to the third over y. Square it, square that, and that. There are 4 of them. So -1 quantity squared times x squared over 2 squared y squared times -4 times y over x. So that's going to give us 1 times x squared, 4 times y squared times -4 times y over x. We got to cancel. We have an x canceling with one of those. We have a y canceling with one of those. We have a 4 canceling with the -4, which leaves us a -1. Lots of stuff out there to get lost. So it's negative x over y. 2 cubed z cubed over y cubed equals 3, not equals, times 3yz over 8. I'm going to be smart. 2 to the third is equal to 8. I can cancel those. My y is going to cancel with one of those. And that leaves me with 3z to the fourth. You have z and z to the third, which equals z to the fourth over y squared. So let's be efficient if we can be efficient. Find the area of a square. Formula for area of a square is s squared, where the side is 3x over 4 squared, which produces 3 squared times x squared times 4 squared, which equals 9x squared over 16. That is the area of the cube. Find the volume of a cube. Volume. Oh, s cubed. Volume. So cubed. And that's just going to equal 2 cubed times n cubed times 3 cubed, which equals 8n cubed over 27. That would be the volume. Much faster. Look at that. That was like 15 minutes. That was a good video. Way to go, 6'2".